Hello dear aspirants, this is Dr. Sourav Sir's class. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076. If you have any doubt, any query or anything, please feel free to call us, or you can WhatsApp on this number, or you can drop an email to our email ID, which is souravsirclasses@gmail.com. Okay. So now we are uh, you can join our regular batches, or you can join our one-on-one sessions or online classes, so that will be beneficial for your preparation of upcoming examinations like ISI CMI entrances. Okay, so please feel free to contact us if you need any help from us. So now we are going to solve a mathematical problem in the which is appeared in the question paper of ISI MTech QROR 2024, and the question is telling us that suppose that f is from R to R, that means real to real, is a differentiable non-decreasing function whose derivative f dash is continuous. Fix a less than b and let s equals to x belongs to x belongs to open interval a to b, f dash x equals to 0. If fa is less than fb, then which of the following is necessarily holds? Option A is telling us that the set S is empty. For B, we can see that they are telling us the set S is finite and non-empty. C is telling us that the set S is countably infinite, and D is telling us that none of the above. Okay. So what can be done? So we are given a differentiable non-decreasing function f from R to R, and our with a continuous derivative f dash, and we define the set S equals to x belongs to open interval AB, f dash x equals to 0. Now we also know that our fa is less than fb, and we need to determine the nature of S. So now we are going to understand the f. Okay, so our f is differentiable on R, means f dash exists everywhere. F is non-decreasing, that means what? That means our f dash x has to be always greater than equals to 0 for all x. And our f dash is continuous, ensuring that f dash does not have any abrupt jumps. And our fa less than fb implies that f is strictly increasing at least somewhere in open interval ab. Means f dash must be positive somewhere. So now we are going to see the options, or check it where it is true or false. So our option A is telling us that our S is empty. Let me evaluate it. So if S were empty, that would mean our f dash x greater than 0 everywhere in this. So however, this is not necessarily true. For example, let us take a function, that means our fx equals to x cube. Then our f dash x is what? That is equals to 3x square. And our let us take the interval -1 to 1. Then we can see that which is 0 at x equals to 0, since our f dash x equals to 0 somewhere, so our S is not necessarily empty. So our option A will be incorrect. So now let us check for our option B. That means in option B, they are telling us that our S is finite, and non-empty. Okay, and non-empty. Yeah. So let me evaluate it. So now if s were finite, it would mean that our f dash x equals to 0 only at a finite number of points. However, due to continuity of f dash, it is possible for f dash to be 0 on an interval or at an infinite sequence of points. Example, our f dash, let us take fx equals to x to the power 4 sine 1 by x. Then what will happen? Okay. So then for x not equals to 0. Okay. So which has infinitely many zeros of f dash. We can easily see that. Thus, our S may not be finite, meaning our option B will be also incorrect. So, let me rule out our option B. Yeah. So, now we are going to see for our countably infinite case. That means which is our option C. Okay. So, yes. Since our f dash is continuous, if it were 0 on an interval, then by the zero derivative theorem, f dash would be identically 0 on the interval, contradicting f a less than f b. This means S cannot contain an interval, it must be discrete. A discrete subset of the interval, open interval ab, can be at most countable. Therefore, S is at most countably infinite always. So our option C will be the correct option of this. That is necessarily holds here. Okay. So now our since our S is at most countable and can be infinite, the correct choice will be our option C. Okay, again I am telling that if you have any query, any doubts or anything, please feel free to contact us via these contact details so you can enjoy all the services of Dr. Sourav Sir's classes. Okay. Thank you guys. Hope you understood. Thank you.